In this video, we're going to learn how to convert between polar and rectangular coordinates. Let's use the following figure to help us establish the formulas that we're going to use. In this figure, we're envisioning laying a polar plane on top of an xy Cartesian plane. The pole and the origin coincide, as well as the polar axis and the positive x-axis. We have a point P plotted in quadrant 1 in the xy plane, but P could lie anywhere, and these relationships we're going to write are still valid. Now, the point P is addressed by the ordered pair x, y in the xy plane, as well as the polar coordinates r, theta. The point P lies on the terminal side of angle theta and is a distance of r from the origin and thus from the pole. We can draw a right triangle where the hypotenuse is the terminal side of the angle theta containing the point P, and r is the length of the hypotenuse since it is the distance from the pole to point P. Now, furthermore, the horizontal leg of the right triangle is the distance indicated by x to the point x, y, and the vertical leg of the triangle is the distance of y of the ordered pair x, y. Well, let's write down some relationships we can observe from this figure. Using Pythagorean theorem, we can write that x squared plus y squared equals r squared. Now, based on definitions of trigonometric ratios, we can also write that tangent of theta is equal to y divided by x, sine of theta is equal to y divided by r, and cosine of theta is equal to x divided by r. Now, for this video, we're learning how to convert from polar coordinates to rectangular coordinates. Therefore, if we have the values of r and theta, we're looking to find the corresponding x and y values. Then we're only going to need to use the last two equations that we wrote, but we will write them in a more convenient form. If we take the equation sine of theta equals y divided by r and we solve for y, we get y equals r times sine of theta. Now, similarly, if we take the equation cosine of theta equals x divided by r and we solve for x, we're going to get x equals r times cosine of theta. These two equations will allow us to find the values of x and y given the values of r and theta. Now, the first two equations that we had written using the Pythagorean theorem and tangent of theta aren't going to be used right now in this video. We'll use those later when we discuss how to convert from rectangular coordinates to polar coordinates. So in summary, the following theorem states, if P is a point with polar coordinates r, theta, the rectangular coordinates x, y of point P are given by x equals r cosine theta and y equals r sine theta. A quick note here about the case when r is negative. The figure that we drew implied that r was positive because the point was in quadrant 1. However, the theorem holds for any value of r. So let's consider the scenario if r is less than 0. Then the point we are converting, r, theta, can also be represented as negative r, theta plus pi, where negative r would be positive since r is less than 0. Now, because cosine of the quantity theta plus pi equals the negative of cosine theta, this equals x divided by negative r. And therefore, x will equal r cosine theta. Similarly, it's true that sine of the quantity theta plus pi equals negative sine of theta, and this will equal y divided by negative r. And therefore, y will equal r times sine of theta. So this just shows us that the conversion equations that we will be using are valid for any polar coordinate r, theta, whether r is positive or negative. Now let's consider an example where we will be converting from polar coordinates to rectangular coordinates. And this problem states, find the rectangular coordinates of the point with the polar coordinates. Part A is the polar point 2, negative pi over 3. Now, if we plot this point in the polar plane, we sketch the pole and polar axis, then draw the terminal side of the angle negative pi over 3. Next, we plot the point a distance of 2 units from the pole along the terminal side of theta. And note, if we overlay an xy grid on the polar plane, that the angle -pi/3 lies in quadrant 4. So to find the x-coordinate, we use the equation x equals r times cosine of theta. Now, substituting in r equals 2 and theta equals -pi/3, we have 2 times cosine of the quantity, -pi/3, which equals 2 times 1/2, which equals 1. Now to find the y-coordinate, we use the equation y equals r times sine theta. Again, substituting in the values of r equals 2 and theta equals -pi/3, we have 2 times sine of the quantity, -pi/3, which equals 2 times the quantity, -√3 divided by 2, that equals -√3. Therefore, the rectangular coordinates of the point P is the ordered pair 1, -√3. And part B is converting the polar point -3, 3π/2 to rectangular coordinates. Now, to plot this point, we have sketched the pole and polar axis on top of the x and y axes. We then draw the terminal side of angle 3π/2, which lies on the negative y-axis. Now, since r equals -3, then we add pi to theta, which places us on the positive y-axis, and we move a distance of 3 units. And note that the point has xy ordered pair of 0, 3 in the rectangular coordinates. Now, even though from the graph we can determine the converted rectangular coordinates, let's go ahead and use the conversion equations just to confirm that result. So to find the x-coordinate, we use the equation x equals r cosine of theta. Substituting in r equals -3 and theta equals 3π/2, we get -3 times cosine of the quantity, 3π/2, and this equals 0, since cosine of 3π/2 equals 0. Now to find the y-coordinate, we use the equation y equals r times sine of theta. Again, substituting r equals -3 and theta equals 3π/2, we get -3 times sine of the quantity, 3π/2. This equals -3 times -1, which is +3. Therefore, the rectangular coordinates of the given point P is the ordered pair 0, 3. And let's note, just as we observed from the graph, that this point would lie on the positive y-axis.